Geometry, week 6, end of summer. And we are going to do quizzes 4, 5, and 6. Oh, man. I only had to do 2 quizzes last week. Okay. Well, it is the last week of summer. I suppose if you don't finish, then you can do them next week. But try to finish because, you know, you should probably take a break too. Let's see. We got dilations, then congruence and similarity transformations. Oh, that's a short one. Yeah. Okay. So let's get started. Quiz 4. Segment A prime B prime is the result of rotating a segment AB by 90 degrees about point P. Select all the correct statements about the unchanged properties of AB and A prime B prime. Okay, so we're gonna read through these and see what we think. So perpendicular means 90 degrees to the x-axis. So is that, let's look at segment AB. Is it perpendicular to the x-axis? Segment AB is perpendicular to the y-axis. See that? The right angle it forms? It's actually parallel to the x-axis. So that's not right. A and A prime have the same coordinates. Well, if you rotate them and that's not the center, then they would not have the same coordinates. AB and A prime B prime have the same lengths. Yes. Okay, so when you rotate, translate, or reflect, your segments will all have the same length. So that will remain unchanged. So there's some properties that remain unchanged after a transformation are called preserved properties. Like a jar preserves, you know, raspberry jam. And so they're preserved, so they're saved. And so what are these? Length, area, perimeter, collinearity, distance, ABCD angle measure. Yeah. So what's not preserved? Location. That means, you know, the points are in different spots, and sometimes orientation, the way that the figure is turned, you know, those things are not always preserved. And these are called, this is the list for congruence transformations. This is the list for congruence transformations, which are reflections, translations, and rotations. Dilations are cool, but they're not congruence transformations. Okay, let's move on. We move on. Okay, the sequence. This one's not that fun, you know, but we're just gonna kind of estimate it. So we're gonna look at the figure, and we are going to follow the rule, you know, approximately. We're gonna eye it and see if it would work. So if you have trouble with this one, put it in the organizer, but don't, you know, freak out. It's good to have seen it before actually starting the class, right? Quadrilaterals L, M, N, O, and ABCD are congruent. The side length of each square is 1. Which sequence. Okay, a translation 6 units to the left and 1 unit up, then reflecting over a horizontal line through point A. So it's like that. We'll take 1 point that we think are corresponding points. So I'm looking and I see that these sides are corresponding sides. And I'm thinking that B and M are corresponding points. Like they're the same point on the figure. So I'm gonna think about moving M and seeing if it would map onto B. So 6 units to the left. 1, 2, 3, 4, 5, 6. 1 unit up. And then reflecting over a horizontal line through point A. So with that, is this point right here a reflection of point B? No. If it was a reflection of point B, they would be the same distance and on the same line from the line of reflection. So sequence A is out. How about sequence B? A 90-degree rotation of point O. Okay, so 90 degrees about point O. Where is point O? It's right here. So 90-degree rotation. So that means we're gonna be out here, right? Draw my line to make my 90-degree angle, and then translate to 60 units to the left. And 1 unit up. I don't really think either of them. Neither of those work. I'm glad it's true, because otherwise I would have to do extra thinking, which is okay. All right, but do you see how I just kind of eyed it and saw whether it would work or not? And that should be sufficient for that one. Give you, a good, making a good understanding, making sense of the situation. And if you get a hard one, put it in the organizer. Okay. So triangle ABC is translated 9 units to the left, 3 units up. Okay. What is the length of A prime B prime? So we know that length is preserved. And so AB is 8. So A prime B prime must also be 8. You see? All right. I'll just let you do that one. Talked about that one enough. Segment A prime B prime is a result of reflecting AB across line L. So then that would make it like this here, something like that. Something like that. Okay. So, but we want to know what's preserved. Okay. So you can do that one. Let me move on to quiz 5. Okay. A prime, B prime, C prime is the image of A, B, C under a dilation whose center is A and the scale factor is 3/4. Which figure correctly shows A prime, B prime, C prime using the solid line? Well, okay. This is a good one. So let's talk about dilations. Dilations are a size change. So your pupil can dilate at the eye doctor. It gets bigger or smaller. And so if our dilations happen by a scale factor, and so what it is we take the side of an image divided by the pre-image corresponding side, and that gives us our scale factor. In this case, we're dividing 2 sides and we get 3/4, which means our image is 3/4 the size of the original. It happens from a center around a center or about a center. It's not a rotation, but it also has a center. And so you have the same distances. So our we always go to the center and we move the same distance to get our new shape. So let me show you which one it should look like. So what's our center? Let's see what our center. Our center is A. So then that means that both the image and the pre-image are going to have a point at A because it is the center and it's also on the pre-image. So C would work, except that, does that red triangle look 3/4 the size of the blue one? I didn't think so. I think D, that's how it should look. So we have our center at A, and then our golden triangle is 3/4 the size of the pre-image. Oh, what a good, all right. Let's see. Pentagon A prime, B prime, C prime, D prime, E prime is the image of pentagon A, B, C, D, E under a dilation with a scale factor 1/2. What is the length of segment C prime, D prime? Okay, so if the image is 1/2 of the pre-image, then it's going to be 1/2 of whatever CD is. So 1, 3, 4. So if CD is 4, then C prime, D prime would be 1/2 of 4. 2. Quadrilateral A prime, B prime, C prime, D prime is the result of dilating quadrilateral ABCD about point P by a scale factor 3/2. Determine whether each claim about the properties of A, B, C, D, and A prime, B prime, C prime, D prime is true or false. So the lengths would not be equal because a dilation does not preserve side length. It actually makes the sides bigger or smaller. And the areas, if the sides are not same length, then the areas will not be the same because we multiply the sides to get the area. Oh, okay, I like this one because I want to actually do a dilation with you. So I was talking earlier about moving the same distance from the center. Now in this one, we actually get to do that. So pay close attention to this and take time to draw it on your paper. So our scale factor is 1/3. See that? So what we're going to do is we're going to find the distance from pre-image to center. So C, our distance from, we always start at the center. Okay? Start at, isn't that where you want to start? Start at your center. Okay? And then move to the point. 1, 2, 3. So you go 3 to the right. And we go 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 up. So I'm going to multiply those distances by 1/3. And then those will be my C prime distances. So C prime is 1 to the right because 3 times 1/3 is 1. 9 times 1/3 is 3. So to get to C prime, I go 1 to the right and 3 up. Okay, now we're going to do the same thing with A and B. So that may have seemed a little mysterious, but now we're going to do the exact same process with A. Start at my center and figure out where do I go to get to A. 1, 2, well, let's start left, right. 1, 2, 3, 4, 5, 6. So this time we're going 6 to the left. And then 1, 2, 3 down. So then I multiply those by 1/3. And I get 2 left and 1 down for A prime. So then from the center, I'm going to go 2 left and 1 down. And that's A prime. All right, last one, B. So let's do that over here. To get to B, I got to go 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 to the left and 1, 2, 3, 4, 5, 6 up. Multiply those by our scale factor, which is 1/3, and we get 3 left and 2 up. So B prime is going to be 3 left from center and 2 up. 1, 2, 3, 1, 2. So now the cool part is, after all that work, we can draw segments between points, and it'll be exactly the same shape as the pre-image, but it's smaller. It's 1/3 the size. Isn't that cool? It's all that math, and then boom, connect the dots, and you can clearly see that we have a triangle that is 1/3 the size. So I better just put my green triangle on top of it. We did it. So good. So good. This one, you can do this one. You don't need my help for that one. Figure it out. All right, last one we're gonna do quiz 6. And this is not a long one, don't worry. Pedro was curious if circles A and B with X and Y being on each circle were similar. Similar means similar implies same shape, different size. That is the geometric definition of similar. Okay. So what did Pedro conclude? It's not possible to map circle A onto circle B using a sequence of rigid transformations, so they're not similar. What? Can't map circle A onto circle B? So one more transformation. All you got to do is shrink circle A and it'd be circle B. And similar means same shape, different sizes. They'd still be circles, you know, and so triangles, other shapes can be different kinds of that shape. Like a triangle could be a right triangle or an obtuse triangle or a skate or an acute triangle. So they wouldn't, those things would not be similar. But a circle, all circles are similar. So Pedro. Mark that down, Pedro. Stefan was able to map triangle ABD onto triangle ABC. Well, if he can map it on, that's good. I was able to map ABD onto ABC using a sequence of rigid transformations. So the triangles are congruent. Yeah. Congruent is the other concept. Congruent. Same shape, same size. So if you can map using a sequence of rigid transformations, then they are congruent. So if he could do it, so we just need to see. So he looks like he reflected them. Yeah, okay. So no, there's no error if he says it. Maybe we made an error. Let's see. We can the sequence. Yeah, that's what I said. He successfully mapped it, but he didn't use rigid transformations. He translated some points more than others. Oh, I didn't even look at that. So he translated. Oh, well, I thought he reflected. I didn't really look at it. He didn't. Oh, because it didn't say it. So notice how point D traveled further than point A. And then some points didn't. Notice. So you have to use the correct, rigid transformations. But I still think that those are congruent. It's just that he didn't use the right one. That's kind of a tough question. Okay. Let's just move on. Okay. Put that in the organizer, you'll be fine. Complete the similarity statement. An equilateral triangle is sometimes, always, or never similar to a scalene triangle because we can sometimes, always, or never map one onto the other using only dilations and rigid transformations. Okay, so an equilateral triangle is, so in order for them to be similar, they're going to need to have the same angle measures. And an equilateral triangle is always going to have 60-degree angles. And a scalene triangle would never have 3 of the same angle. So they would never be similar. So an equilateral triangle is never similar to a scalene triangle because we can never. All right. Segments A, B, and CD coincide. Segments A, B, and CD have no angles with the same measures, so they are not congruent. So no angle there. Vinay. Segments are mapped onto each other, so they are congruent. The segments are not congruent because, okay. All right, so they coincide, so they are congruent. You see, they are mapped onto each other. But he said they're not congruent because they have no angle. So the segments are mapped onto each other, so they are congruent. Okay, so Vinay is confusing things. He was thinking about triangles or something. With angles, there's no angles there. Bastian was able to map quadrilateral OPQR onto ONML using a reflection and a dilation. Bastian concluded, I was able to map quadrilateral blah onto quadrilateral blah using a sequence of rigid transformations and dilations. So the figures are similar. Okay. See if we can redeem ourselves here. So he says they're similar. And they look similar to me. And then the other thing is, so we need to look at this little diagram to see what transformations he used. And so it looks like, okay, so let's look and see that OPQR, which is this blue triangle, is the pre-image. And it looks like did he reflect it? And this is this dashed thing, a reflection of the original. And then he used a dilation to make the figure bigger. And so he said they're similar. So we're going to say Bastian used a reflection. Yep, that's okay. And he used a dilation. That's okay. And so it's okay. All right, so we learned from the first one. I learned from the first one. I have to look at the picture to see what transformations the student used in order to see if their justification is correct. And with that, we have finished our prep for high school geometry. You're going to do great. Just make sure you have captured in the organizer what you know, need to practice, and what you still need to learn, and you're going to be golden. Bye, guys.